So today we're going to be doing the 6.3 quiz for the periodic for algebra. Now let's start. So the first and second term of geometric progression are these two. What's the common ratio? Common ratio is second term divided by first term. This is the same as multiplying by the reciprocal. So 2 will cancel out with this, will become 7 times 5, which is 35. Moving on to the next question. What's the sum of this geometric progression to infinity? Now the sum to infinity of a GP is equal to G1, which is the first term, over 1 minus common ratio. Common ratio, you get it by dividing G2 over G1. Which is, in this case, you cancel 12 with 12 when you divide them, so you're going to get 0.7. So G1 is 12 over 1 minus 0.7. You should get 40, which is 12 over 0.3. Yeah. Now moving on to the next question. They want what's the 10th term. Now to find the geometric progression, it's G1 times R to the power of n minus 1. So first term is 2, 7, or over 3, 6, times R, which is the common ratio 3 over 2, all to the power of n minus 1. N is 10, so it's 9, which is 10 minus 1, 9. Put this all in your calculator, you should be getting this answer. Now let's move on. For this question, it's just you need to find how much do you divide by each time. Each time here you could get that by doing 100 over 1000, cancel zeros with each other. You're gonna get, you're dividing by, it's 1000 over, you're dividing by 1 over 10. That's your common ratio, which is you're multiplying by 1 over 10, which is the same as dividing by 10. So you're dividing by 10 each time. So 100 divided by 10 gives you 10, 10 divided by 10 gives you 1, 1 divided by 10, 0.1, 0.1 divided by 10 is 0.01. You could do that, or you could just do 1000 times the ratio, that's G1 times the ratio 1 over 10 to the power of n minus 1. Both work. This one's faster if you're doing it not on paper. If you're on a written part, you must do this. If you're just doing it in the exam and they ask you 3rd, 4th, 5th, 6th, like in sequence, just divide by 10. I find that personally better. Moving on to the next question. Okay, geometric progression, first term is this, ratio is this, first term, 1/2 times radical 2 to the power of n minus 1. Now G3 to the power of that, when you put it in your calculator, you should be getting 1. Now G4, it's 7 minus, they want G7. 7 minus 1, which is 6. Put it on your calculator, you should be getting 4. Now for G11, you're just going to do the same thing. Just replace the 7 with 11, 10. Same thing, you're going to get the answer 16. All of these are done on calculator. Calculators are allowed in the exam. So it shouldn't really take that much thought from us. Just putting numbers in a calculator for the entire exam. Now for this question, write this repeating decimal. Now what part of a repeating decimal is a geometric progression? It's the part that repeats. 1 doesn't repeat, so our geometric progression is 1 plus 0.090909. What is 090909? Isn't it just 9 over 100? So our geometric progression is 1 over 9 over 100, then 1 plus 9 over 10,000, it's 4 zeros, then 1 plus 9 over, and you keep adding 2 zeros as you go, right? That's our geometric progression. So what's the common difference? The common difference here is 100. 1 over 100. Divide it, you're gonna get that that's your common difference. When you divide 9 over 10,000 by 9 over 100. By the way, if you want to know if it's 1 over 10 or 1 over 100, look how many numbers are repeating. 0, 9, 2 numbers are repeating. So then it's 1 over 100. If it was 1.99999, then it would be 1 over 10. But yeah. So now we put the 1 aside and we do the sum to infinity of this. So it's the first value is 9 over 100 Keep the 1 to the side, we don't need it. Minus 1 over 1 minus 1 over 100. Put that into your calculator. We should be getting this all equals 1 over 11. So 1 plus 1 over 11. 1 represents 11 over 11, by the way. So 11 over 11 plus 1 over 11 gives you 12 over 11. And that's your final answer. So when you're putting into your calculator, you could either put this whole thing or just put this and then add it to 1, whatever you like. Both will work. Now, if you're doing it on the computer, in the written exam, sorry, not on the written part, on the computer part of the exam, the best way to do it, honestly, is just write 1 point, then keep spamming 0909090909 on your calculator, like spam it like 10 times, and then press equal. It should give you the same answer in the exam. Like, that's if you're short on time and whatever. You could even do that, and then later when you're done the entire exam, check. That's what I usually do, but yeah, that's how you do it. Next question. Okay, find the sum of the first 12 terms. Now, how do you do this? You just get your formula, which is G1 into 1 minus r to the power of n over 1 minus r. And when you put all your numbers in, the first term is 1 into 1 minus, the ratio is 3 to the power of 12 over 1 minus 3. Put that all in your calculator. This is your answer. And now, since we know in the quiz we get answers like this, if you see an answer this big in the exam, don't be weirded out. Now let's move on. What's the value of the sum of all the terms? By the way, another thing I forgot to add, your common ratio for you, if you want to find the sum to infinity, your common ratio should be between 1 and negative 1. It should be bigger than negative 1, yet smaller than 1. If your ratio is smaller than negative 1 or bigger than 1 or equal to any of the two, you cannot find the sum to infinity. It's impossible. You can't. Only, so now here our common ratio is 500 over, which is 5 over 10, which is 1/2. It's less than 1 and greater than negative 1. So now we could do it. So it's 1000, it's our first term, 1000, over 1 minus 500 over 1000, which is the same as 1 over 2. And you get this answer when you do it on your calculator. That's it. Let's move on to the next question. This, we've already said it already, how to do it. You keep the 2 aside, and then your geometric progression is basically 14 over 100. Then 2 plus 14 over 10,000. Then so on. So our common difference is 1 over 100 again. Why? Because you're repeating 2 values, 14. That's the 2 values that are keeping repeated. So it's 2 over plus, 14 over 100 plus over, 1 minus 1 over 100. Let me put it quick in my calculator. 14 over 100 over 1 minus 1 over 100. You get 14 over 99. So it's 2 plus 14 over 99. Now what's 2? 1 is 99 over 99. So 2 is basically 99 times 2 over 99. 99 times 2 is 198 over 99. Right? Because it's they have to divide by 2. And you need your denominator to be the same. So now, when 198 plus 14 gives us 212 over 99. Now to check if it's the simplest form on your calculator or lowest terms, you just put the number 212 over 99 on your calculator, press equal. If it gives you the same number, then that's lowest term, and then if it gives you a different number, then you could have simplified more and just put that answer instead. Again, only do this if you have a written part. If you do not have a written part, just like I said, 2 points, then spam 14 a lot. Just keep spamming 14 And then you should also get the same answer. That's how I usually solve it on computer parts. Now let's move on to the next question. Okay, this question, most parts of it have nothing to do with this quiz, but let's solve it anyways. You need to find the nth term for each of these sequences. For this sequence, we can tell it's a geometric progression. Why? Because when you divide 12 by 3, gives you 4. 48 by 12 gives you 4. 192 by 48 gives you 4. So our term is 3 times 4 to the power of n minus 1. That's our sequence. They're just asking you to find the sequence. See? That's how you get your sequence. For the second one, try. If you divide it, it won't do anything. But 11 minus 7 is 4. 15 minus 11, 4. 9 minus 15, 4. Now this one, it's a 7 plus common difference, 4 to n minus 1. So you can expand plus 4n minus 4, which is the same as 3 plus 4n. That's your sequence for the second term, for v. See? Now for this one, you need to look at the numerator and the denominator is the same. What happens in the numerator? It's plus 1, right? This is the first term. First term plus 1. So it's n plus 1. Now, this is the first term, right? And this is the second term. What happens? 1 plus, how much gives you 5? 4, right? So n plus 4. Let's try it. This is the second term. Is 2 plus 1, 3? Yes. Is 2 plus 2 plus 4, 6? Yes. And that's basically how you solve it. It shouldn't take that much thought. Last one, we have to do something else. We need to first try subtracting. When you subtract 5 from 12, you get 7. 25 from 12, we get 13. 44 from 25, we get 19. Now again, 13 minus 7, 6. 19 minus 3, 6. So what's this? It's what's it called again? Not cubic sequence, it's a quadratic sequence. So what do you do now? We know that in a quadratic sequence, you need to memorize 3 things. A1. Wait, what do you need to memorize? I genuinely forgot for a minute. Oh wait, yeah, I remember. It was in our IG. 2a equals this number, which is 6. Now 3a plus b equals this number, which is 7. And a plus b plus c equals 5. Now what do you do with this? You start from the bottom. 2a equals 6, so a equals 3. 3 into 3 plus b equals 7, right? So 9 plus b equals 7, so b equals negative 2. Now c, a, which is 3 plus negative 2 plus c gives you 5, which is 4. So now c is 4. So a is 3, b is negative 2, c is 4. You just put those numbers into your equation. 3, negative 2, and 4. And that's it for this question. Let's move on to our last question. What's the sum to infinity of a geometric series if the first term is 48 and the second term is 36? Now to find the ratio 36 over 48, which is 3 over 4. Now we said the formula is G1 over 1 minus R. So 1 minus 3, 4. And you get 48 over 1/4, which is the same as 48 times 4, which is 192. And that is your answer. That's the end of this quiz. Hope you had a nice day. Goodbye.